Okay, let's take a look at this problem. For how many n, which element of the set 1 through 500, is the n a multiple of 1 or more, 5, 6, or 7? Okay. 5, 6, or 7. I'm going to refer to this just, let me use letters. F for 5, um, X for 6, and V for 7. Since my S's don't come out very well, that part works out best. So if I focus on first on the 5, so I'm trying to find the cardinality of 5s. Well, if I think what multiple means you keep adding the number over and over. 5 plus 5 is 10, plus another 5 is 15, 20, and so forth. Now, if I focus on a smaller number like 15, which is in our list, 15 divided by 5 tells us 3, and there are 3 going up to there. So it appears like if I take my number and divide by 5, that'll give me how many my cardinality will be. So I'm going to 500. So I'm going 500 divided by 5. That gives us 100. So cardinality of F is 100. Seems like a lot. Let me think about that. 15 divided by 5 is 3. 500 divided by 5. Yeah, it is 500, isn't it? Yeah. Okay, so if I think about 6, same idea, 6, 12, 18. And if I were to take a smaller number like 18 divided by 6, that gives me 3, and I see there's 3 elements there. So it appears like if I take 500 divided by 6, let's see, that goes in there 8 times. 6 times 8 is 48, so 20, and I'll probably screw this up if I don't write it down. Okay, 48, 20, 3, and we got decimals, but you want to drop off the decimals because you always want to go round down, because if you round up, well, that's a number past 500. Okay, and then 7. Again, same principle, that's 7, 14, 21. So I take 500, divide by 7. 7, 49, 10. Okay, so that'd be 71 where I round down, just drop off the decimals. So my cardinality of 6, which I said is X, is going to be 83. And the cardinality of 7, which I labeled as V, is going to be 71. Okay, so if I add these together, so I'm going to have 100 plus 83 plus 71. And let's see, that's 4, 8, 9, 10, 15. I'm not very good at basic math. 15, that looks right, 254. The problem is the ones we count twice. And I started looking up formulas for divisibility rule and try to think, was there something related to that? And then I started thinking about it from a different standpoint. For example, if I'm looking at the intersection of f and x, which is 5 and 6. So the numbers that they would have in common, if I'd kept going here, this would have been 25 and 30. this would have been 24 and 30. You notice they both have a 30, so I counted that twice. So I need to subtract that off, and that's the principle of inclusion exclusion. So then I started, originally I was thinking, okay, well, fives, if they're divisible by 5, they end with 0 or 5, and then if they're divisible by 6, that means they're divisible by 2 and 3. And then I started thinking, well, if it's divisible by 2, the last digit is 0, 2, 4, 6, or 8. If it's divisible by 3, all the digits added together. And then I started thinking, boy, this can't be this complex. So really, what we have to consider is these two numbers multiplied together. For example, 5 times 6, or 30. And then we had to figure out how many of these. For example, if I multiply this by 2, 2 times 30 is 60. Both of these go into 60. If I multiply by 3, 5 and 6 both go into 90. So then I would take my 500 divided by, and I'm going to figure out how many 30s. Same principle as above. I should have a calculator. I got a calculator on my desk. What am I doing doing this by hand? 500 divided by 30, and I get 16.666. So again, I want to drop off. So that means there's a total of 16 of them. So this would be 16. If I did the cardinality of the intersection of f in 7, so 5 and 7. Well, 5 times 7 would give us 35. So if I take 500 divided by 35, gives us 14.28. So again, I'll drop them decimals, and I got 14. And what's one I'm missing? X and V. X is 6, V is 7, so 6 times 7 is 42. And 500 divided by 42, 11.9, so I'll go to 11. So that's 11. Okay, now the other thing I have to consider is the cardinality of the three together. So F and X and V, which is 5 times 6 times 7. That's 210. And 500 divided by 210 gives us 2 point something, so 2. So then, this is going back to our cardinality of a union of 3 sets. We'll take our F plus, or cardinality of F plus cardinality of X plus cardinality of V minus cardinality of the intersection of F and X minus the cardinality of the intersection of F and V minus the cardinality of, oops, let's get that right, Control Z, X and V minus, no, not minus, plus, because we have to add that back on. Cardinality of F and X and V. Well, this is 100 plus 83 plus 71 minus 16 minus 14 minus 11 plus 2. Up above, we said that was 254, that first part. Minus 41 plus 2. And that gives us 215. Now, I will tell you, this has been a challenging problem for me. I was trying to go about it the hard way before I just thought about what multiples actually represent. So that's a little bit of a challenge. Once I started clicking here, and then I made the connection between the intersection of them and that, then it was a little bit easier. Anyway, that's that problem.